This video is going to continue with chapter 9.6 and then get into 10.1 and the chapter prereq chapter from Calc. So 127 says for 127, 131, it says to sketch the graph of the polar equation by hand and then use the graphing utility to verify. Well, again, we're not going to have the graphing utility to verify. You can use it to check your answers, but you won't have it on your test. Number 127 is r equals 5. This is simply a circle that goes all the way out to 5 in all points. So it would be something like that. 131 is 5 cosine theta. So this is a circle. Remember, when you think back to all your different types of polar graphs, there's something where it's just a number times cosine or times sine, and that's a circle. There's one where you're adding or subtracting a number to sine or cosine. And this is a limison. There's one where you have, well, these are all r equals. R equals a number, so it could be a, and then sine or cosine, and a number like 2 or 3, or let's say cosine. These would be roses. And then the last one would be if it's r squared equals the same thing. So this would be a squared sine 2 theta or a squared cosine 2 theta. And those are lemniscates. So when you just look at 131, you should know that that is a circle. And you know that the quick test for symmetry is if it's sine, then it's going to be symmetric to theta equals pi over 2. And if it's cosine, then it's going to be symmetric to the polar axis, which is also like the x-axis. And then if you wanted to test symmetry, then if you're testing for pi over 2, you're going to take r and theta and replace them with negative r and negative theta. If it's a test for the polar axis, then you're replacing just theta with negative theta. And if you're doing the pole, then you're replacing r theta with negative r, positive theta. So looking at 131, we know that this is symmetric to the polar axis. And then from there, we want to plug in some points. So I would start by plugging in theta as 0. Since it's polar axis, we know that whatever happens on top is going to happen on the bottom. So I would plug in points from 0, pi over 4, pi over 2, 3 pi over 4, and then I would do pi and then reflect that over the bottom. So 5 cosine theta would be 5 cosine of 0. Cosine of 0 is 1, so this is 5. 5 cosine pi over 4 is 5 times root 2 over 2. We're going to approximate root 2 to be 1.4. So this would be 5 times 0.7 or 3.5. 5 cosine pi over 2. Cosine of pi over 2 is 0, so this is 0. 5 cosine 3 pi over 4 is negative root 2 over 2. So this would be negative 3.5. And then 5 cosine pi would be 5 times negative 1, which is negative 5. So when I go to plot those points, I'd have 0, 5. I'd have pi over 4 and 3.5. I'd have pi over 2 and 0. And 3 pi over 2, negative 3.5. So 3 pi over 4, sorry, not pi over 2, would be here. But because it's negative, we're moving it away from it here. And then pi is here, but because it's negative, we're moving it back over here. So we know that this circle would look something like that, with the furthest point from the pole, from 0, being your r, which in this case is 5, or your a, sorry, the number on the front of your trig function. All right, so I pulled in the cheat sheet kind of for the limicons. Remember, when you're looking at A over B, if it's less than 1, it's got an inner loop. If it's equal to 1, it's a cardioid. If it's in between 1 and 2, it's dimpled. And if it's greater than or equal to 2, then it's convex. So when you look at 133 and 135, you should know that these are both limicons because you're adding and subtracting something to it. So 133, your A is 5 and your B is 4. Because that's bigger than 1 but less than 2, this is going to be a dimpled limicon. We also know because it's cosine, it's got polar axis symmetry. So I would start with the same angles that we did as the last one, which would be 0, pi over 4, pi over 2, 3 pi over 4, and pi. So if I plug that in, 5 plus 4 cosine 0. Cosine of 0 is 1, so 5 plus 4 times 1 would be 9. 5 plus 4 cosine at pi over 4. 5 plus 4 root 2 over 2, which is 2 times root 2, which we're going to say, again, this is like 1.4. That means that's 2.8. That's 7.8. Five plus 4 cosine at pi over 2 is 0. 4 times 0 is 0, so this is 5. 5 plus 4 cosine at 5 pi over 4, actually 3 pi over 4, sorry, would be 5 plus 4 times negative root 2 over 2. 5 minus 2 root 2, which we said was 2.8. 5 minus 2.8, which is 2.2. And then 5 plus 4 cosine at pi, which is 5 minus 4, which is 1. So when we graph these, we're going to do 0, 9. So I'm actually going to make these 2, 4, 6, 8, 9 would be just beyond there. So 10 would be here. We're going to do 0, 9. We're going to do pi over 4 and 7.8. So there. Pi over 2 and 5. So if this is 2, 4, this would be 5. 3 pi over 2 and 2.2. And pi and 1. And then whatever's happening above it is happening below it. So let me erase these marks. So I'd know that this would also be 7.8. This would also be, so pi over 2 was 5. This would also be 5. This would also be 2.2. And this would go back into 1. So my dimpled limicon looks something like that. All right, we're going to do 135 down here. 135. The A is 3. The B is 5. This is less than 1. So if we go back up to the top, we know that that makes this an inner loop. It's sine this time, so we know it's symmetric to the pi over 2 line, which means everything that's happening on the right is going to double back onto the left. So when we pick our thetas, we're going to pick the ones on the right. We're going to pick 0. We're going to pick pi over 4. We're going to pick pi over 2. And then we're going to pick 7 pi over 4 and 3 pi over 2. And we're going to plug it into that 3 minus 5 sine theta. So 3 minus 5 sine at 0. Sine at 0 is 0. That means that this is 3. 3 minus 5 sine at pi over 4. 3 minus 5 times root 2 over 2. So we're going to approximate that to be like 2.5 times 1.4 or 3.5. And then 3 minus 3.5, negative 0.5. Then 3 minus 5 at sine pi over 2. Sine at pi over 2 is 1. So this is negative 2. 7 pi over 4, 3 minus sine, 5 sine. This is 3 minus 5 times negative root 2 over 2. So that's like 3 plus 3.5 or 6.5. And then 3 minus 5 sine at 3 pi over 2. Sine at 3 pi over 2 is negative 1. So this is 3 plus 5 or 8. And then I'm going to go graph those points. So 0, I'll make them 2, 4, 6, and 8. 0, 3 pi over 2 and negative 0.5 means it's this way. Or pi over 4, sorry. Pi over 2 and negative 2. 7.4 and 6.5. And 3 pi over 2 and 8. Okay, so then we're going to duplicate them over the pi over 2 line. So everything's happening on the right-hand side. I'm going to duplicate over onto the left. So this point is going to, this point would match this point. This would match this point. And that little one would match that little one. So I know I've got a loop. Or something like that. All right, 137. We're going to work over here. All right, so what I should be able to identify from this is that this is a rose. Remember, rows, the number on the inside determines the number of petals. If it's an even number, you double it. If it's an odd number, you keep it. So because that's a 2, I know that there are 4 petals. I know this is cosine, which means it's going to be symmetric to the polar axis. And then I know that R is 3. So I've got to basically use my poles and my angles in between until I find that 3 to know which way those petals are going to come out. So I'm going to start with the same ones. 0, pi over 4, pi over 2. And then I want to flip it over the polar axis, so I'm going to keep going into 3 pi over 4 and pi. So negative 3 cosine 2 times 0. Negative 3 cosine of 0. Cosine of 0 is 1, so negative 3. Negative 3 cosine 2 pi over 4 is negative 3 cosine pi over 2. Cosine pi over 2 is 0, so that's 0. Negative 3 cosine 2 pi over 2. Negative 3 cosine of pi. Cosine of pi is negative 1. Negative 3 times negative 1 is 3. So already I've got a pattern forming. I know at 0 it's negative 3, so it's actually going to be here. I know at pi over 2, it's pi over 4, it's 0, so I'm coming in at that point. I know at pi over 2, it's 3. So here's a petal, here's a petal, and this is symmetric. So this is also a petal here, and this is also a petal here. If I continued on with that pattern, you would have seen the same thing occurring. If I had done negative 3 cosine 2 times 3 pi over 4, this would become 3 pi over 2. At 3 pi over 2, cosine 0, negative 3 times 0 would be 0, so that would come back in. And then at negative 3 cosine 2 pi, that's a 1, so negative 3 times 1 would be negative 3. So this would be 0, and this would be negative 3. And that's where I would have gotten my additional petals. Okay, 139. R squared equals 5 sine 2 theta. So here's my lemniscate. I know that because it's R squared. I know lemniscates are symmetric to the pole. And then I can do my other test to see what else this is symmetric for, or I can just plug in my points. The other thing you should know from this is that your A squared, which is the number on the front, so A squared equals 5, which means A equals the square root of 5. That's the furthest point you're going to get. So if I start with theta, 0, pi over 4, pi over 2, and see where we go. R squared equals 5 sine 2 times 0. R squared equals 5 Sine at 0 is 0, so r would equal 0 there. R squared equals 5 sine 2 pi over 4. 5 times sine pi over 2. Sine at pi over 2 is 1. R squared would equal 5, and r would equal square root of 5. So I know that that's how far out it's going to go, which means the 0, 0 is going to be here. The pi over 4 root 5, which we're going to say is just a little bit bigger than 2, is here. And that's going to be the one part of my infinity. These are symmetric to the pole, so I know that it's going to come out on the other side here. And that would be where the other half of the lemniscate is. So the lemniscate, you really only need to find that one petal, and then it will duplicate to the other side. All right, last one is 140. R squared equals cosine 2 theta. So again, this is a lemniscate because it's r squared. My a is 1, so that's how far it's going to go, and it's obviously symmetric to the pole. So if I start with 0, pi over 4, pi over 2, and let's see what happens from there. I'm looking for 1. 1's going to be the longest side. So r squared equals cosine 2 times 0. R squared equals cosine of 0. Cosine of 0 is 1. R squared equals 1, so r equals 1. So at 0, I already have my first part of my lemniscate. My assumption is it's going like this. You can always plug in additional points to check to make sure. Like possibly plug in pi and see what happens there. So if I had r squared equals cosine 2 times pi, cosine of 2 pi is 1, and r equals 1. And it confirms that this point would be here. Pi over 2, I would have been brought back into 0. 3 pi over 2 would have been brought back at 0, and that would have confirmed my lemniscate shape. All right, for chapter 10, we moved into the 3D coordinate system. So for the first one, it says plot both the points in the same three-dimensional coordinate system. For the first one, so if you use the coordinate system that's on the left there, moving forward 5 would be here. To the left, 1 would be here. And then up 3, 1, 2, 3. This would be your first coordinate point. For the second one, moving back 3, moving right 3, and then not moving up or down at all, and it would be here. Number 3 says the point is located in the xy plane 3 units to the right of the xy plane. So we moved right, or sorry, to the xz plane. That means that your y is 3. 5 units behind the yz plane means you moved back 5. So that's negative 5. And then it says it's in the xy plane, which means it didn't move up or down at all. So you get negative 5, positive 3, and 0. Okay, number 5 says to find the distance between the 2 points. So we're just using the distance formula with 3 variables. 5 minus 4 squared plus 2 minus 0 squared plus 1 minus 6 squared. I get the square root of 1 squared plus 2 squared plus negative 5 squared. Square root of 1 plus 4 plus 25 square root of 30, which can't get reduced, so it's left the way that it is. Number 9 says to find the midpoint of the line segment. So I'm going to add negative 2 plus 2 over 2, 3 plus negative 5 over 2, and then 2 plus negative 4 over 2. I get 0 over 2, negative 2 over 2, negative 2 over 2, or 0, negative 1, negative 1. Number 13 says find the standard form of the equation of the sphere with the given characteristics. So it is x minus h, which is 2 squared, plus y minus k, which is 3 squared, plus z minus j, which is 5 squared, equals r squared, which is 1. (17) says find the center and the radius of the sphere. So we're going to complete the square. X squared minus 4x, y squared minus 6y, z squared. There's not another z, so that one's already done. Equals, I'm going to bump the 4 to the other side. Take the 4, divide it by 2, and square it. It's 4. Add it here and here. Take the 6 divided by 2, it's 3 squared, it's 9. Add it here, and then the z I don't have to worry about. X minus 2 squared plus y minus 3 squared plus z squared equals, these cancel, 9. Which means my center is 2, 3, 0, and the radius is the square root of 9, which is 3. Okay, chapter P was all the algebra 2 review and the review for calc. So these first ones, 36 was rational equations. You had to look to see if you could factor any of the denominators, which in this one you can. Then find your least common denominator, which is going to be x and x plus 3. Multiply all of them by that. Cancel from what you can. So for the first one, the x cancels, and I get 6 times x plus 3. For the second one, the x plus 3 cancels, and I'd get 2 times x. And then the last one, the whole thing cancels, and I'd get 3 times x plus 5. Distribute. Come by my like terms. Subtract the 3x. Subtract the 18. And I get x equals negative 3. With these equations with ones and variables in the denominator, you've always got to check your answer. So if I take negative 3 and plug it in here, I'm fine. But if I take it, plug in here or here, I'm going to get a 0 in my denominator, which means this would get ruled out and there would be no solution. (62) is your even root property. So when I go to square root both sides of this equation, I want to make sure I remember to put plus and minus. I'd get x minus 5 equals plus and minus the square root of 30. And then I'd add the 5. So x would equal 5 plus and minus the square root of 30. If 30 could be reduced, I'd reduce it, but it can't, so it's going to stay the way it is. 76 was solve by completing the square. So we're going to group these together. 3x squared plus 9x. I can bump the 5 to the outside, or I can move it to the other side. It doesn't matter. I'm going to eventually end up doing that anyways. So it'll be negative 5. Take the 3 out here. Take the 3, divide it by 2. It doesn't go unevenly, so I'm going to leave it at the fraction squared, and I get 9/4. I'm going to add that here, and I would normally add it here, but before I do that, I have to multiply it by the 3. So I'd be adding 27/4. So I get 3x squared plus 3x plus 9/4 equals, this becomes 20/4 or 7/4. Divide both sides by 3. Just 7/12. This becomes x plus 3/2 squared. Square root both sides. This becomes square root 7 over square root 12, which is square root 7 over 2 root 3, and then I have to rationalize it. So square root 21 over 2 times 3, which is 6. So I'd get x equals negative 3/2 plus and minus the square root of 21 over 6. Number 83, it says to solve this using the quadratic formula. So I want to get everything to one side in order. So negative 9x squared plus 12x plus 3. And A is negative 9. B is 12 and C is 3. So negative B plus and minus the square root of B squared minus 4 times A times C all over 2 times A. negative 12 plus and minus the square root of 144. It's 36 times 3, 108. Oh, negative 18. So then this breaks down to 2 and 1, 26, 2 and 63, 9 and 7, 3 and 3. So I get negative 12 plus and minus. There's a pair of 2's and a pair of 3's. So that comes out as 6 root 7 over negative 18. And then that gets reduced because 6 goes into each of these two. 1, 3. So I would change the signs on them because this is negative. And I'd get 2 plus and minus root 7 over 3. $114 is solve by factoring. So we want to get everything to one side. And then there's 4 terms, so we're going to factor by grouping. From the first 2, you can take out an x to the third. From this next 2, you can take out a negative 8. And I get x plus 2 and x to the third minus 8. So then either of those equals 0 and the whole thing equals 0, which means we can split it and solve it. This would be x equals negative 2. And this would be x to the third equals 8, and x equals the cube root of 8, which is 2. So I get negative 2 and 2. $124, I want to get just the radical on the side by itself, so I'm going to move this over. Square root of 3 minus 2x equals 2. Square both sides, and I get 3 minus 2x equals 4. Subtract the 3, I get negative 2x equals 1, and x equals negative 1/2. Because there's a square root in my initial question, you always want to check these. So I would take it, plug it back in. I get the square root of 3 minus 2 times negative 1/2 minus 2 equals 0. 3 plus 1 minus 2 equals 0. Square root of 4 minus 2 equals 0. And 2 minus 2 equals 0. So it works. 140 is your absolute value. So this is an equals problem, which means what's inside the absolute value can equal positive 12, and it can also equal negative 12. So I would subtract x equals 11 over 13, subtract, and x equals negative 1. So my two answers P2 is my inequalities. Subtract whatever you do on the inside of my combined inequality, you have to do to both sides. And if it said to graph this, negative 1, 3, it would be an open dot or a parentheses shaded in between. Here I've got an inequality with absolute value. So the first thing you got to do is get the absolute value on the side by itself. And then when you read this, this is read as less than. This becomes an and statement with an opposite of what's here on the left. And then whatever you do to the inside, you have to do to both sides. So I get negative 10 is less than negative 2x, which is less than negative 8. Divide by negative 2, and when you do this, it's going to flip your inequality sign. So I'd get 5 is greater than x, which is greater than 4. So in order from left to right, that'd be 4 is less than x, which is less than 5. And in a number line graph, it would be 4, 5, open dot, or parentheses shaded in between. 113 is my inequality with quadratic. So I want to get everything to one side. factor it. Positive 3, negative 2, and I get x equals negative 3 and x equals 2. Those become your test points. So negative 3 and 2. And then you want to plug numbers in each of these areas. So if I say negative 4, and then 0 and 3, and see what works. You can either plug it in here or here. It doesn't matter. So let's say I plug it in the top. Negative 4 squared plus negative 4 is less than 0. That's 16 minus 4 is less than, not 0, 6. And I get 12 is less than 6. That's not true, so this doesn't work. 0 squared plus 0 is less than 6. 0 is less than 6, so this works. 3 squared plus 3 is less than 6. That's 9 plus 3, or 12, which is not less than 6. So I know what works is from negative 3 to 2, and it would be an open dot or parentheses shaded in between. Okay, P4 is finding your x and y intercepts. So the first thing I want to do is plug in 0 for x to find the y-intercept. And I get y is 0. And then I want to do the y, so 0. I can take out a 2x squared here, and I get x minus 4. So 2x squared equals 0. Divide by 2, and x squared equals 0. So x equals plus or minus 0, which is still 0, which is consistent with what I found for the x-intercept. But then I also have x minus 4 equals 0, so x would equal 4. 31, y squared equals 6 minus x, so plug in 0 for x. Y squared equals 6, so y would equal plus and minus the square root of 6. And then plug in 0 for y, and x would equal 6. Number 81 says to plot and then find the slope. So 5 and negative 7 would be here, and 8 and negative 7 would be here. Y2 minus y1 over x2 minus x1. Negative 7 minus the negative 7 over 8 minus 5 becomes 0 over 3, which is 0. 56 is find the equation of a line through 8,2 with slope 1/4. So I'm going to plug it into point slope. And then 88 is find the equation of a line that is A parallel to this given line through that point, or B perpendicular to it. So the first thing I want to do is find the slope of this line. Negative A over B tells me that that would be -1. So if the line is parallel to it, I'm going to keep it the same. So I would get that slope. And if it's perpendicular, I'm going to change it, sign, and flip it. So a positive, it's still 1 though. And then I use this point. So y minus 2 equals -1, x plus 3. And y equals -x minus 1. And here y minus 2 equals 1 times x plus 3. Y minus 2 equals x plus 3. Add the 2, and y equals x plus 5.